All right, 7.5, operations with radicals. You're going to multiply and divide. Those will be the big ones, and you're going to add and subtract. And you know a lot of this already. So here is just simplifying. So kind of like what we have been doing, but you're going to have some stuff left over. And so you still need to break that down, but the 32 is not going to have a perfect square root. So it breaks down to 2 times 16. So that 16 is hiding in the 4 squared. So imagine that we just had 16 x to the 8th to break down. That 2 is just left over, so it's going to stay under the square root. And if we did the 4th root of 16, a 24, b to the 13th, the 16 we can break down, the a to the 24th we can break down, but the b to the 13th, that does not have a perfect 4th root. B to the 12th would, so that's the b to the 3rd to the 4th. It has an extra b tagged on, so if we break that out, then we could 4th root everything else, and then we would just have an extra b that would stay under a 4th root. So that's what's sitting there. Addition, subtraction, your radicals are going to act like terms, variables. So you need to break them down. We have already tried to do these square roots before, earlier on, chapter 5. So square root the 98 as best as you can. So that's 2 times 49. You want to go for the highest square root you can out of these numbers. And 32 is 2 times 16. You already have that 2 hanging out in front. So you can square root the 16, which is where the 4 comes from. The 7, of course, is the square root of 49. And you just go down further and keep on simplifying. The 2 already out in front of the 2 square root 32, you multiply by the 4, which is the square root of 16. And so you get 7 square roots of 2 and 8 square roots of 2. And treat the square roots of 2 as if they were x's. So like terms, you can subtract those radicals, and you're left with a negative 1 square root of 2. And same thing, if you have more than one. If you notice the final answer on this has 2 different radicals, of course they wouldn't go together. It's kind of like you have x and y. You can't add and subtract them. And it works out like the problem before. So make sure you take the time to write it down. You're just breaking down the numbers to the largest perfect squares that are factors. So the 12 is a 3 times 4, the 27 is a 3 times 9, the 128 is a 2 times 64. So within the 12, the 4 was perfect square, so its square root is the 2. Within the 27, the 9 is a perfect square, so it's one of the 3's that comes out. The other 3 is not a square root, so you can't do that. The 64, its square root is an 8, so it's what is out in front. And then you continue simplifying. So like the 5 times 2 is 10, the 2 times 3 is a 6. And then you put together the radicals that are the same. And then you've just got distributive property, and you need to keep track of what you multiply together. What is under a radical is not a whole number, so you can't do 4 times radical 3, or square root 3. What are under radicals, like the square root 3 and square root 2, the very front term, you can multiply those together. So square root 3 and square root 2 is square root 6 in the 12 square root 6. So in between subtraction and addition signs, those are terms. 4 square root 3 times 6, I can multiply the whole numbers that are in front. So that's my 24 square root 3. Then 5 square root 2 times 3 square root 2. The square root 2's, you get square root 4, which is a 2. So you have 5 times 2 times 3. And that gives you the whole number 30. And then 5 times square root 2 times 6, you've got 5 times 6, which is 30. Then you have the square root of 3, or 2, excuse me. And that's as far as you can go with that problem. And then rationalizing. We had done this with complex numbers. Eventually I'll let you do that in the calculator. This you won't be able to do. Again, we have a conjugate, only this is a radical conjugate. Again, with the opposite sign, you keep the terms the same. You just change the sign in the center. And we have distributive property. And you just got to keep track of what you're multiplying by. So 2 times square root 5. Ooh, I see a mistake that I made. So we will need to correct that in our notes. So 2 times square root 5. If you correct it and you get back in class, bonus points. Okay? So I can see it. We will definitely go over this problem. Find it, find it, find it. So you need to distribute, and you have double distributive on the bottom. And you'll see you have two terms that cancel out on the bottom. So all you're left with is 5 minus 1, so you have the 4. And then the 4 divides into the first term and into the last term. So you can reduce the 2 and the 4, the 2 in front of the square root 5 over the 4. And then you have the fraction at the end. So we'll need to go over that mistake if you find it. And then this is also rationalization. This is the last bit of the notes. You want to make the bottom a perfect nth root, whatever it is. So you only have a single 5x. You can't fourth root that. There's no exponent to cancel out with the index. So if I do 5 times 3 more 5s, I will have an exponent that matches up with the index of 4. And the same thing with the x's. It doesn't matter what happens to the top. It's just going to be whatever's left over. So I get a fourth root of 5 to the 4th, so those can cancel out, and a fourth root of x to the 4th, so that those can cancel out. And then I just multiply whatever's on the top. And that's how I get my final answer. So come with questions. I hope you found the mistake on the second to the last slide.